Alright guys, you know the drill at this point. Go ahead and make sure that you have lesson 23 written in the top left corner, today's date right there in the middle, and the topic of the day, which is standard algorithm division, written in the top right. And go ahead and draw your lines here for your notes. This is going to be a very interesting day. Basically what I've done is run you guys all around the ring, making it hard for you, making you do all this work, and today I'm going to finally give you the very end thing the very last thing that you need to know to divide large numbers. This is what everybody does. This is called the standard algorithm. And you're going to be like, Mr. Reed, why didn't you just show us this way of doing it from the beginning? It's so much easier. Well, it's because if you don't really understand what the numbers are doing, then it doesn't make sense for you to do it this way. Because basically you're just a calculator. If you can't explain what the numbers are doing, then you shouldn't be doing it. So, the learning target for today is I am able to successfully divide multi-digit dividends by multi-digit divisors using the standard algorithm. We've been doing things that look very similar to the standard algorithm, but are not quite the same thing. And there's a key difference I'm going to show you here. Well, I guess right now, let's go ahead and jump in, shall we? Alright guys, this problem is going to be a little bit different. What I want you to do is not write anything down when I solve this the first time. I want you to just watch me, and then I want you to go back to this point, and I want you to try solving it on your own. I know you'll know the answer, but I want to see if you can do the steps. Pause it if you need to on the way through the second time, but this is the first time we're actually going to use the standard algorithm. We're still going to use our format of estimate, solve, and check, but it's going to look a little bit different. So I'm going to go ahead and get started here. I can't round 3 anywhere, it's just one digit, so our divisor is going to be 3 for our estimate. And I'm thinking 300, I know 3 will go into 300, I know 3 will go into 60, and I know 3 will go into 9, but it's a little bit too much to think of all at once. I'm going to round 369 to 360 because I know that 10 groups of 3 is 30, I know that 11 groups of 3 is 33, and I know that 12 groups of 3 is 360. So, here we have this problem. We have 360 is the same as 36 tens divided by 3, which is the same as 12 tens, which is the same thing as 120. So that is the estimate that we're going to be using. Now the problem actually really starts. So I've got my problem set up here, 369 divided by 3. Now what I'm going to be looking at is this very first digit, and I'm thinking, can 3 go into 300? Now I'm thinking, okay, this isn't really a 3. What it really is 3 hundredths. So I'm going to divide 3 hundredths by 3. And I know how many times exactly that 3 will go into 3 hundredths. It will go in 100 times. So what I'm going to do is put a 1 right here, and I'm going to take away those 3 hundredths. And what will happen is I'm going to get a 0. Now I'm not done with my problem yet. I have this 6. So what I'm going to do is I'm going to go ahead and bring down the 6. But it's not really a 6, it's 6 tens. So again, I'm going to write over to the side here my next problem. So what I'm thinking is 6 tens divided by 3, that just equals 2 tens. 3 will go into 6 twice. 3, 6, done. So 2 tens equals 20. But I'm just going to put the 2 in the tens place. And this is what's so important. When you put these here, you have to make sure that they're in the correct place value, because we said it will go 100 times, not 110, not 1, 100. Again, here it will go in 20 times, which is the same as 2 tens. So we're going to put the 2 in the tens place. And we're going to continue now. So we're going to take away 6. And again, we're done. 6 minus 6 is just 0. Now I need to bring down the other digit, which is going to be 9. Now this is just 9 ones, but again, one more time, I'm going to write my work on the side here. I have 9 ones divided by 3. Well, that just equals 3 ones. So 3 is going to go above the ones place. I'm going to go ahead and finish my problem. 9 divided by 9, 9 subtracted by 9 is 0. Now we're ready to check, because we're done with our problem. Alright, I'm checking here and I see that 3 times 3 is 9, 3 times 2 is 6, 3 times 3 is 3, so my answer is just 369. That's my dividend right here. So I know I did this very quickly, but this is our answer right up here. 123 is our answer to this problem. Now let's move on to a more complicated problem. All right, here we have a much larger problem, but it's not going to be that much more difficult. So let's go ahead and start by estimating. So 29 will obviously round to 30. This part's a little bit more hard though. So we have 6,247. Now again, I'm thinking threes. I know threes, if I'm skip counting by threes, I'll never hit a 2, I'll never hit a 4, I'll never hit a 7. I'm going to round those up to an even 300. So that'll be 6,300. And remember what we talked about before, if we have big numbers like this, we can get rid of a 0. We'll just divide both by 10. It's the same thing. So I'm going to get 630 divided by 3. And let's just rewrite this to make it a little bit easier too. We're doing all these things to keep track of our numbers and to make things easier. So I'm just going to write this as 63 tens divided by 3. And let me just tell you my thinking here. So I know 10 groups of 3 is 30. I know 20 groups of 3 is 60. And if I add one more group of 3, that would be 63. So that would be 21 groups altogether, which would leave me with 21 tens, which is the same thing as 210. So right now we have an estimate of 210 for how many times 29 will go into 6,247. So it should be right around there. Let's try solving it. So I'm going to set up the algorithm here. I want you to try and do the same thing. Alright, our problem is set up, so I'm going to go ahead and start thinking about how I can start dividing. So my divisor is 29, and my number is 6,247. So when you divide with the standard algorithm, you always look at the very first digit, and you say, can my divisor go into this first digit? Well, can 29 go into 6? No, it can't. But can 29 go into 62? Absolutely. So what I'm going to think is how many times will 29 go into 62? And remember, this isn't really just a 62. It's 6,200, but we're going to treat it like it's a 62 right now. So let's think, how many times can 29 go into 62? I bet probably about 2 times, because 29 is really close to 30, and 62 is really close to 60, and 30 will go into 60 twice. But let's just check real quick. Just to be safe, I'm going to do the algorithm real quick here over to the side. And we're going to say 29 times 2. 2 times 9 is 18. 2 times, and we regroup that, 110. So 2 times 2 is 4, plus 1 is 58. That sounds perfect. So our hundreds place, and again, we're going to put the 2 right above the 2, because this 2 is the hundreds place, and 29 will go into 6,200 200 times. So that is very important. You don't want to put the 2 above the thousands or above the tens, because that would make this 2, which is supposed to be 100, either 2,000 or 20, and we need it to be 200. So very important. Now we know that 29 times 2 is 58, so let's take away 58. And we'll get 4. If we just count up 59, 60, 61, 62, that's going to be 4. That's why I didn't regroup and everything. I can just skip count up. Now 29 will not go into 4, correct? 29 can't go into 4. So we need to bring down another number, and our next digit right here is 4. So let's see. How many times are you thinking 29 will go into 44? That's our new problem. Well, we knew that 2 times was 58, and 58 is larger than 44, so it can't possibly go in twice, but I know it can go in once. So I'm going to put 1 right here above the 4, and we'll take away one group of 29. The reason I'm changing colors here is to just sort of keep you aware of what place value is what. Okay, so here I'm going to regroup this 4 into a 3 and regroup this into 14. 14 minus 9 is 5. 3 minus 2 is 1. Now again, I have one more problem here. So this definitely worked, but 29 can't go into 15 right here. So what's got to happen is I have to bring down the 7. So we have 7. Now I have no idea how many times 20 will go into 157, but I have a pretty good guess. Again, I'm going to pretend 29. I'm just going to keep doing estimates here. I know that 29 is really close to 30, and I can skip count. I can skip count really easily here. So I'm going to say 30, 60, 90, that's 3 times. 120, that's 4 times. 150, that's 5 times. So I'm going to try multiplying 29 times 5. Let's see what happens. Let's see what the number is. 5 times 9 is 45. We'll regroup those 4 tens. 5 times 2 is 10 plus 4, which is 14. So our answer is 145. So let's take away 145. 7 minus 5 is 2. 5 minus 4 is 1. 1 minus 1 is 0. We are at the end of our number right here. There are no other digits over here to bring down, so I can't bring any more down. And again, we used 5 groups of 29, so we need to make sure we put a 5 above the ones place. And we are also done right now with our math because we can't get any more groups of 29 out of 12, so that's a remainder. So we have a remainder of 12. So right now we have an answer of 215 with a remainder of 12, which is really close to our estimate. So our estimate served us well. Turns out our actual answer was a little bit more than our estimate. But again, we need to check this real quickly here. So let's see what it's going to be. All right, so I've shrunk this down. But here is my formula here. We have the divisor times the quotient plus the remainder, which equals the dividend, or D. So I put my answer that I'm going to put right up here. So I'm going to go ahead and write out the algorithm real quick. Here we are. 9 times 5 is 45. Oops, excuse me. 45. Regroup the 4. 9 times 1 is 9, plus 4 is 13. We'll regroup that 1. 9 times 2 is 18, plus 9 is 19. We'll put our place value or placeholder right there. We don't need these guys anymore. 2 times 5 is 10. That's a 0. We'll regroup that 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4. So let's add everything up. 5 plus 0 is 5. 3 plus 0 is 3. 3 plus 9 is 12. We'll group the 1. 1 plus 1 plus 4 is 6. So we have 6,235 plus 12. 35 plus 12 equals 6,247, which is our dividend. Absolutely. So right up here, our dividend is 6,247, which is the same thing that we have in our answer up here. So again, our answer of, drumroll please, because I know this is very long, 215 with a remainder of 12. Or if you want to get fancy, you can put 12 29ths is absolutely correct. And that is the last problem we'll solve today, but we do need to look back at our notes very quickly. All right, we're just checking back really quickly because we need to fill in this part of our notes for dividing by place value, because that's what we did today. So I'm going to type these in. I want you to pause and copy them down. Here it is. I want you to write in your journals, this is the fastest and easiest way to divide, and Mr. Reed has been hiding it from us. This is a really, really important lesson to make sure you have really good notes on, because you're going to want to look back at that problem and want to put a little note here, a little asterisk, to look at 3 as the divisor and 369 as the problem. You guys just solved that. Look back at that problem if you're not understanding things. Look back at it until you really understand it, okay? And because you're going to have that to be able to work on the problem set. You may need to watch this video a few times. Next, what I want you to do, again, just like before, put a 1, a 2, a 3, or a 4, and circle whichever one you feel like you are. So if you're a 2, you may be a 2 on this one. Circle it and say, I'm a 2 because, and why? What are you having trouble with? Because if you put that down, I can probably help you. I hope you enjoyed this lesson, and I bet you'll probably be watching it a few more times. Hope you guys have a great day.